Welcome to our lesson on simplifying fractions. In this lesson, we're going to talk about how to simplify expressions that involve fractions by teaching you how to add them, multiply them, subtract them, and even divide them. Okay, so the first thing I want to do is I want to show you how we can actually multiply two fractions together. So let me start with a simple fraction and we'll figure out how to multiply it together. Okay, so before we try a random fraction times another fraction, I just want you to think about what 2/3 times 6 would be. Well, here we have 6 items. And if we want 2/3 times 6, well, that's going to be the same thing as 2/3 of the 6 items. So in other words, this is going to be 2/3 of 6. Or, that's just going to be the same thing as the number 4. When you see a fraction in a multiplication like this, I want you to read it a little bit differently. Instead of reading it as 2/3 times 6, read it as 2/3 of 6. And then from here it's pretty obvious why the result is 4. Because here you have 6 items. This is going to be 1/3 of those items, and this is going to be 2/3 of those items. This generalizes pretty easily when you start thinking of taking fractions of other fractions. Now this time I want you to think of taking 2/3 of 4/5. Well, to figure out exactly how that works, I'm going to start by actually drawing 4/5 as a pie. Okay, so here I've got a pie, and it's been broken up into exactly 5 parts. And 4 of those parts have been highlighted. So we have 4/5 of a pie in this region over here. Okay, so now we're saying that we'd like to take 2/3 of this whole 4/5 that we drew over here. If we're going to do that, the easiest way by far is going to be to break up each of these pieces into thirds. And then when you do that, you can just mark out 2 of them and do this for every single slice. Okay, so as you can see, I've gone ahead and broken each of these fifths into thirds. And now what I'm going to do is I'm going to take 2 of each of those thirds. So I'm going to go ahead and color in 2 for each one of these. And now if you think about it, since we started with 5 parts, and then we broke each one into 3, that means we have 15 parts in total in this new picture over here. And now because we started with 4 parts that were highlighted, and we took 2 parts from each highlighted part, then in total we're going to have exactly 8 parts that are highlighted. Okay, so that means 2/3 of 4/5 is the exact same thing as 8/15, because there are 15 parts and you've taken 8 of them. So this is going to be the same thing as 8/15. But to make this a little bit more useful, I just want you to realize that this 8 is the same thing as 2 times 4. And it makes sense that it's the same thing as 2 times 4 because we've taken 2 parts of 4 original slices. And then after this we can see that 15 is the same thing as 3 times 5. And this also makes sense because each of these 5 slices that we started with, we've turned into 3 parts. So it makes sense that we have 15 now. Okay, so one thing I am going to say here is that there's nothing special about 2, 3, 4, or 5. I just picked them at random. But one thing we can say is that if you repeated this exact same thing for absolutely any numbers, you'd always come to the same conclusion, that you just multiply the top numbers and then multiply the bottom numbers. And because of this, I'm going to replace this 2 for an A, I'm going to replace this 4 for a B, and then I'm going to replace this for C, and I'm going to replace this for D. So this is just telling us that if you want to multiply some fraction by another fraction, all you have to do is to multiply the numerators by each other and then multiply the denominators by each other to get the final result that I've shown here. So next, we want to turn our attention to dividing 2 fractions by each other. How exactly is that going to work? Okay, so if we're going to divide a fraction by another fraction, I just want you to remember what this division sign means. If we write something like 3 divided by 4, I want you to remember that that's the exact same thing as 3 on 4. So let's use that to rewrite this as well. And then if we wanted to continue this analogy, if we had something like 3 divided by 4, we could always write this as 1/4 of 3, or 1/4 times 3. And that means we can write this as 1 divided by this number times this number on the top. And then after this, I want you to remember that, for example, 1 on 4 is the exact same thing as 4 reciprocal. And that means 1 on this 7 on 6 is the same thing as 7 on 6 reciprocal. And as we know, the order of multiplication doesn't really matter, so I'm just going to swap the order. And now this actually brings us to a really important point. If you want to divide a fraction by another fraction, that's the exact same thing as multiplication by the reciprocal of the second fraction. But then I guess this leads us to one more question here. How do we find the reciprocal of a number like 7 on 6? Well, it turns out that doing that isn't really so hard either, and we can do it just by using the index laws. So let me go ahead and show you that too. Okay, so let's start by taking the reciprocal of a number, like 5 on 2. We said that 5 on 2 is going to be the same thing as 1/2 of 5. So let's replace that. Now, as we discussed in our lesson on the index laws, we already said that we could write 1/2 as the number 2 to the power of -1. So let's replace that as well. Now, the index laws tell us that we can always take this -1 and multiply it to each of these two terms. So let's do that as well. But before I actually do the multiplication, I just want you to notice that -1 times -1 is the same thing as 1. So when I multiply these, this is going to disappear, and this is going to get a -1. Now we'll just write the reciprocal of 5 as 1 on 5. And then we know that this is the same thing as 1/5 of 2, which we can just write as 2 on 5. And then from all of this, the only thing I need you to remember is that the reciprocal of 5 on 2 is the same thing as 2 on 5. So if you like, you can remember it like this. To take the reciprocal of a fraction, just swap the numerator and the denominator to get the result. And because there's nothing special about the numbers 5 and 2, I'm just going to replace them for a and b as well. Now because we know that a divided by b is the same thing as b divided by a, then we know that the 7 on 6 reciprocal is the same thing as 6 on 7, so we can replace that as well. Then as we found earlier, to multiply these two, you just multiply the tops, and then you just multiply the bottoms. So then after all of this, we can clearly see how to actually divide 5/3 by 7/6. All you have to do is multiply the 5 by the 6 to get the top, and then multiply the 3 by the 7 to get the bottom. So in other words, you multiply the top by the bottom, then the bottom by the top. Now again, there's nothing special about the numbers I've chosen here. So let me again replace them for A, B, C, and D. Now, despite the fact that I've used numbers to solve all of these problems, it is perfectly possible for you to come up against a problem that includes variables rather than just numbers. So let me give you one of these problems and we'll work through it together. Okay, so in this example I've written over here, we want to divide a fraction by another fraction. We can see that we're dividing 2x plus 1 divided by x minus 1 all over 3 minus 2x divided by 2x minus 2. Now the first step here would be to realize that dividing two fractions is the same thing as multiplying by the reciprocal. So let me go ahead and do that first. Now we can just take the reciprocal of this term over here to write it as 2x minus 2 divided by 3 minus 2x. Because remember, you just flip the denominator and the numerator when you want a reciprocal of fraction. Now at this stage, it looks like we're more or less done, but we should look to simplify things even further. We can't really simplify 2x plus 1. We can't simplify x minus 1, but we can actually take a 2 out as a common factor for this term over here. We also know that multiplying two fractions is the same thing as multiplying the tops and then multiplying the bottoms. So if I multiply these tops and these bottoms, then I get the following. Now I just want you to realize that this x minus 1 on the top is exactly the same as the x minus 1 on the bottom. So that means we can just go ahead and cross them out. And then we can just expand the numerator to get 4x plus 2. So then after all of this work, we just notice that this massive expression over here simplifies to this simple expression right down here. And this is the reason why you'd want to be able to simplify things like this. Sometimes you can take a really complicated expression and re-express it as something much, much simpler. And this is a very handy thing to be able to do. Okay, so now I think it's just about time that we talked about addition and subtraction as well. So first I'd like to add the fractions 5 on 6 and 3/4. In order to do that, I'm going to draw 5/6 of a pi, and then I'm also going to draw 3/4 of a pi as well. So we want to try adding these 5 tiles to these 3 tiles here. But of course the really big problem is, these tiles are actually smaller than these tiles on the right. So one thing we're going to have to do in order to add them is we're going to need to make the tiles the same size somehow. Now to do that, I want you to realize that 6 is the same thing as 3 times 2, and 4 is the exact same thing as 2 times 2. So if we look at the denominators of both of these, we notice that this one over here is missing a 3, and this one over here is missing a 2. So here's what we can do. If we break these 6 in half, and we break these quarters into 3 parts, I want you to notice that we're going to have exactly the same number of parts in both of these pictures. Okay, so now if you look carefully, both of these have the exact same number of parts. In this case, we multiplied the 6 parts by 2 to give us 12 parts, and in this case we multiplied the 4 parts by 3 to give us 12 parts as well. Now I want you to notice that the exact same amount of pi is highlighted in both of these examples. So we haven't changed the amount of pi that we've got, but we've just changed the number of pieces that we've cut it up into. So initially we started off with 5 of 6 pieces and 3 of 4 pieces. Now in this example over here, because we started off with 5 parts selected and broke each one in half, we now have 10 parts selected. And because we started off with 6 parts and again broke them in half, there is a total of 12 parts over here. And now in this pi we had 3 parts selected, but each one's been broken up into 3. So now we have 9 parts selected in total. And because we started with 4 parts and broke each one of them into 3, we have 4 times 3 or 12 parts in total. Okay, so because in the first pi we've selected 10 out of 12 pieces, and then in the second pi we've selected 9 out of 12 pieces, well, in total we have 19 twelfths of a pi. Now what we've done here mathematically is also pretty interesting, so let's look at how we did this. I want you to notice that 5 on 6 turned into 10 on 12. So that means we just multiplied the 5 by 2 and the 6 by 2 as well. So that's the same thing as multiplying by 2 on 2. And 2 on 2 is the same thing as 1. Now if we look at this second pi over here, what we've actually done is we've multiplied the 3 by 3 to get 9, and then 4 by 3 to get 12. So in other words, we've multiplied this by 3 on 3, which is also equal to 1. And now because both of the denominators of these two are 2 times 2 times 3, we were able to just go ahead and add the tops directly. Now this just immediately tells us that in order to add two fractions together, like this one and this one, you just have to multiply both of them by 1, and the one you choose needs to make both of the denominators exactly the same. Now in general, when you do try to add two fractions like this, it is a really good idea to just find the lowest common denominator. The simple temptation can be to just multiply this by 4 on 4, and then to multiply this over here by 6 on 6. That will always work, but you should be careful because it can significantly complicate a problem that you're trying to solve. But if I did go ahead and replace all of the numbers for A, B, C, and D, then something a little bit different happens. Now because I don't really know what all of these letters equal in general, I can't really give you the lowest common denominator of C and D. The best I can really say is that the lowest common denominator is going to be C times D. So therefore, the best I can really do is to multiply this term over here by D on D, and then I can multiply this term over here by C on C. Both D on D and C on C are going to be equal to 1, so it is perfectly okay to multiply by them. Now despite the fact that I did multiply by D on D and C on C, I will always prefer to use the lowest common denominator if I can. But at either rate, because we know the denominator here is D times C, and the denominator here is also D times C, we can just write this all over a common denominator. So now we have a simple method we can follow to add two fractions. You multiply the top of the first by the bottom of the second to get dA, then you multiply the bottom of the first by the top of the second to get BC. After this you multiply the two bottoms to get DC, and then you just rewrite them in this form over here. Now before I give you an example, let's also think about subtraction as well, because it's just a special case of addition. Now subtraction is so similar to addition that I'm just going to go straight for the general case here. We know that if you start with some number and then subtract another, you can just write this as the first number plus negative the second number. Now we can also say that negative b on d is the same thing as minus 1 times b on d. And as we've already seen a few times here, we can just multiply this number by the b to rewrite this as negative b. And now we've just turned this back into the problem of addition again. The only difference is that we have a minus b here. So we're going to do the same thing. We multiply this by this, then this by this, and then we multiply this by this. And then finally we know that plus minus bc is the same thing as minus bc, so we just get rid of this plus. So from this we can just see that subtraction is exactly like addition, but we just swap the plus signs for minus signs. And that's basically it. Okay, so I guess the only thing left to do is to show you an example. So let's put up an example and work through it together. Okay, so for this problem, we want to work out how to simplify 5 on x squared minus 5x plus 6 minus 3 on x minus 2. Okay, so the first step to do this is to just find the lowest common denominator of these two. Now immediately, you'd think to just multiply this by this and then this by this. But I'd say that that's actually a bad idea. So what I'd do instead is I'd actually go ahead and factorize this, just like I decided to factorize the 6 in the original problem and the 4 in the original problem. Factorizing both denominators will allow me to actually find the lowest common factor, so then multiplying is as easy as possible. Okay, so I'm not going to explain how to actually factorize x squared minus 5x plus 6, because I have a whole video on that. You can go ahead and watch it if you'd like to figure out how to factorize quadratics. But if we just went ahead and did this, we'd see that this simplifies to x minus 2 times x minus 3. Now, just in case you're unhappy about that, remember that you can always expand it to see that it'll come back to this original expression. Okay, so in this case, the lowest common denominator is actually x minus 2 times x minus 3, and not all of this times this. So instead, all you really need to do is to add the x minus 3 over here. Now, in order to actually add this x minus 3, you just multiply it by x minus 3 on x minus 3, which of course is the same thing as 1. And now, because we have the same denominator in both of these cases, we can just go ahead and combine them into a single fraction. The next thing you have to do is to actually expand these brackets over here. But be very careful of this minus 3 over here. Honestly, I've seen so many people make so many mistakes because they didn't expand it properly. So if you expand it, you'll get minus 3 times x, and then minus 3 times minus 3, which is the same thing as 9. And then we just finish by realizing that 9 plus 5 is the same thing as 14, so we add them up to get 14. So therefore, we can say that if you have 5 on x squared minus 5x plus 6, and you subtract 3 on x minus 2 from it, you will always get 14 minus 3x on x minus 2 times x minus 3. Now, one thing I recommend you try, just so that you can see how much more work it would be, is to try multiplying this top by this bottom and this top by this bottom, just as we showed over here. If you just go ahead and blindly do this, you'll see that you'll need to do way more work to get to this final answer over here. And therefore, for this reason, I always say that you should try factorizing the denominators and looking for lowest common factors, because if you do that, you may save yourself a heap of work. But that just about completes all the examples I wanted to show you for today. Okay, so now I'd just like to summarize everything. First, we talked about multiplying two fractions. We found that in order to multiply two fractions, you just multiply the tops and multiply the bottoms to get this over here. After this, we turned our attention to division. And in order to find division, we had to first look at the reciprocal. We found that the reciprocal of a fraction is just what you'd get by flipping the top and the bottom, so you just get b over a. Armed with this knowledge, we were able to show that AC divided by BD is the same thing as AD divided by CB. But the way I really prefer that you remember this is that division is exactly the same thing as multiplication by the reciprocal. Once I showed you an example of how to multiply and divide two fractions, we then turned our attention to addition. We found that if you want to add two fractions together, you can use this cross method where you multiply A by D, B by C, and then C by D. If you do this, you get AD plus BC on DC. We then found that you get exactly the same thing when you subtract the two fractions, the only difference being that this minus is a minus here, instead of being a plus. Now, as a parting piece of advice, I really recommend that you get very familiar with the algebra of fractions, because after all, fractions are going to show up quite a lot throughout your mathematical career, and you want to be able to add them, multiply them, divide them, and even subtract them. But I suppose at this point, this just about completes everything I wanted to say about simplifying fractions. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.